Hello, my dear students. Welcome to the today's session. In our previous discussion, we were discussing about the nature of light. Light travels in the form of electromagnetic radiation. Light has wave property with the frequency, amplitude, all those parameters we have studied in our previous discussion. This is given by James Maxwell and some other scientist. So why we study this nature of light? Because nature of light is required to understand Bohr's theory. Already we have studied Bohr's postulate. Our next discussion is why and when or where Bohr failed in explaining correctly the structure of atom. He has done his uh, research work, but still he was in a position not to explain properly the structure of atom. So where he has failed, what are the drawbacks? To explain these limitations or to understand what Bohr has explained about the structure of atom, so we should know the nature of light. So in that we studied on the electromagnetic nature of light. So light travels in the form of electromagnetic radiation. That means energy is radiated in the form of an wave known as electromagnetic wave, which is associated with the two fields. Those two fields are electric field and magnetic field. That's why electromagnetic fields are not affected by these two fields. They travel without any obstacle. Even in the vacuum also they travel. So this was the understanding we studied in our previous discussions. Now today we study one more interesting nature of light, that is particle nature of electromagnetic radiation. Light is an example for electromagnetic radiation. Therefore, we study particle nature of light. For this, the big contribution is Max Planck. Isaac Newton in the past he has said same idea, but now we study in the modern physics or the modern chemistry the special theory given by Max Planck. That theory is known as quantum theory, which we are going to use to explain the Bohr's model and its limitation and plus further structure of atom. So we have to study Max Planck's uh, theory known as quantum theory. What he has said, you see here. A scientist is happy not in resting on his attainments but in the steady acquisition of fresh knowledge. After achieving something, a scientist should not keep quiet. He should not rest. No rest till we become the best. So, fresh knowledge he has to acquire. So, that is the meaning of this statement. So, we have to keep learning every year, every moment. This one, no great discovery was ever made without a bold guess. That means we have to speculate, we have to guess, we have to observe, we have to think, we have to ignite. So all these will go for a great discoveries. That is the meaning of the statement given by the famous scientist of the world, Sir Isaac Newton. He is also very famous, Max Planck from Germany. So we start particle nature of electromagnetic radiation. New experiments showed that the wave model of light needed to be revised. Wave model can be used to explain certain properties of light. For example, diffraction, interference, polarization that you are going to learn in the 12th physics. So they can be explained by the wave nature of light. But there are some properties we can't explain with the help of wave nature of light. So we require something extra. There wave theory fails. So that means one more theory we required so that with that theory, we can explain some more properties. For example, there are two properties in the 11th class which are explained on the particle nature of light, not on the wave nature of light. Those two properties are what? Photoelectric effect and black body radiation. So these two properties of light are explained only on the particle nature of light. That's why he said wave model of light needed to be revised. So we want something extra from the nature of light. The wave model of light cannot explain why heated objects emit only certain frequencies of light at a given temperature. This we study in the black body radiation. Or why some metals emit electrons when colored light of a specific frequency shines on them. This comes under the photoelectric effect. So we study both in 11th class. So one by one. First we go to the photoelectric effect. The photoelectric effect is a phenomenon in which electrons are ejected from the surface of a metal when a light is incident on it. These ejected electrons are called photoelectrons. Whenever you bring a light radiation and make it to fall on the metal surface, electrons are ejected. So here we are using the light. So the word is photolysis, photography, photochemical reaction, photosynthesis. So this photo word we use for the light. So using the light radiation on some metals, he said some metals. Why? There are some metals where electrons are loosely bound to the nucleus. So they can be ejected or removed easily with help of light energy. So when the light energy falls on the metal surface, certain metal surface, electrons are ejected, and those electrons are called as what? Photoelectrons. And the effect is called as what? Photoelectric effect. Let us see the second point. It is important to note that the emission of photoelectrons and the kinetic energy of the ejected photoelectrons is dependent on the frequency of the light that is incident on the metal's surface. That means we are allowing ray to fall on the metal surface. So it is having some frequency. How much frequency? That frequency should be large enough. Why? Because already electrons are having attraction towards the nucleus. There is electrostatic force of attraction between nucleus and the electron of that metal. So now we have to select such a light whose frequency is more than the frequency of the electron that is associated with the nucleus. Then only we can remove. If the frequency is not large or not more, then we can't remove the electrons. Then there is no photoelectric effect. Therefore, we have to use such a light whose frequency is more, because frequency is related to the energy. Max Planck gave one famous equation, E equal to h nu, or energy is directly proportional to the frequency. More the frequency, more is the energy. Less the frequency, less is the energy. So if you remove the proportionality sign, E is equal to h into nu. H is the proportionality constant, which is known as the Planck's constant. It is the work of Max Planck. So whenever we multiply the Planck's constant and the frequency of the light, we get some energy, and that energy should be more than the energy which is there between the nucleus and the electron. Then only electrons are ejected, otherwise no. That is the meaning of the statement. The process through which photoelectrons are ejected from the surface of the metal due to the action of light is commonly referred to as photo emission. Electrons are called as photoelectrons. Emission is called as photo emission, and the effect is called as what? Photoelectric effect, because these electrons will move, then the current also movement is seen in the what electric meter. So it is called as a photoelectric effect. The photoelectric effect occurs because the electrons at the surface of the metal tend to absorb energy from the incident light and use it to overcome the attractive forces that bind them to the metallic nuclei. An illustration detailing the emission of photoelectrons as a result of the photoelectric effect is provided here. You see, this is a metal surface. Let it be sodium or potassium or cesium or rubidium or magnesium or calcium. Okay, so one sample. So they contain electrons, right? Now electrons are having attractive force with the nucleus. So that means they have some attraction force. Now you have to allow light to fall on this metal surface. When it falls with such a frequency whose energy is more, then that energy is transferred to these electrons. Then these electrons get energy, so they become more active in such a way that the attractive force between the electron and the nuclei in that metal weakens and the bond breaks, attachment breaks, affinity breaks, affection breaks between the electron and the nucleus of that atom, and electrons are made free, and those electrons will come out of the surface. This can be detected in the there is a device is there, so you can easily identify the movement of electrons. So to eject these electrons we require light of frequency which is more than this. Every metal is associated with certain frequency, these electrons. That frequency is known as what? Threshold frequency. Threshold frequency is the minimum amount of frequency associated with the electron present with in the atom. So now we have to bring such a light whose frequency is more than this threshold frequency. Then only photoelectric effect is there. By chance, if you bring light of a frequency which is less than the threshold frequency, no photoelectric effect. Or if you bring such a incident light whose frequency is exactly equal to the this threshold frequency, then it may have a small impact. But if you want a good result, you should bring such a light whose frequency is more than, very much more than threshold frequency. Then only photoelectrons are ejected or emitted out. Photoelectric effect is there, otherwise no. This I told. Now this is diagrammatically explained. And in tomorrow we go for a small equation. So threshold frequency and its energy, incident light's frequency and its energy, difference of that energy, how much energy comes out after the difference, where we use that difference energy, all we study in tomorrow's small derivation on the photoelectric effect. Thank you boys and thank you students.